Hello and welcome. This is Chapter 0, Section 6 on matrix operations. Here are our main objectives for today. So let's talk about matrices or a matrix. Matrices are the plural. So they can be used for lots and lots and lots of things. And they use them a lot in computer science and data and a lot of other things, computer graphics, cryptography. We'll talk about this on the next slide just to show you some potential instances. Now, what we do when we write a matrix, it's just going to be numbers inside of kind of like these brackets. Whenever there's an equal sign, we're going to put a vertical line where that equal sign is. And then we literally just write down the coefficients or the number. So 3, 9, 2, -3. Well, it's in front of x. Well, there's a 1 and a -1. So matrices just take and get rid of the variables and write the numbers. And if there was an equal sign, we do a vertical line. This is called an augmented matrix, where we have a matrix, a 2 by 2 matrix. It's two rows by 2 columns. And then augmented meaning we have solutions or answers or equal sign on that side. And we can augment it like doubly, and that'll be something we get into when we talk about inverse matrices as well. So here are like some of the ideas of what you can use matrices for. A lot of in going to computer graphics and video games, a lot of coding things, cryptography, engineering, some basic econ and business, some AI stuff and machine learning, obviously, image processing, and some navigation and GPS. These are just some of the certain instances you can see. So a kind of an example is using just to rotate in a two-dimensional space, like in a video game. So we're going to use this matrix, rotation matrix. The 2D rotation is derived using sum and difference identity, using polar coordinates and stuff, using cosine signs and stuff. We're not going to get into that, but that would be that rotation of 90-degree counterclockwise matrix. And what we can do is with that is we can multiply it to a point, and we can rotate that point by just multiplying the two matrices. So when we rotate it 90 degrees, we get a new point of -4, 3. So literally using matrix multiplication, which on a computer or calculator is fairly fast. It will do this really easily, and we will be learning this matrix multiplication very soon. It's actually pretty simple, and we could get that new point using just numbers. So let's just start playing around with some matrices. We're going to do scalar multiplication. One thing to note is each part inside is called an element. So -7 is an element, 5, -4, -1. Those are all elements. And we're going to find 3 times A. We're taking a scalar. A scalar is just a number, like 3, and we're multiplying it to matrix A. So all we have to do is, if I think about 3 times this matrix A, it's literally multiplying every element by 3. So what this is equal to is we're doing 3 times -7, 3 times -4, 3 times 5, and then 3 times -1. And that will be my final matrix 3A. So 3A, 3 times A, is in fact equal to this matrix here of -21, -12, 15, and -3. So another example is you can multiply by negative numbers as well. So -4D is in fact equal to -4 times this matrix to -3, 7, -4, 5, and -6. And again, we're kind of distributing it to everything inside of it, if you want to think of it that way. We can rewrite this as then -8, +12, -28, +16, -20, and +24. Again, we're just multiplying -4 to every one of these elements of this matrix. Now, what if I added 2 matrices? The first thing is adding 2 matrices, they have to be the same size. They have to be the same size in order to add or subtract. If you're adding or subtracting, they must be the same size, but multiplying, which we'll talk about later, does not have to be the same size. They have to be something, but not the same size. They can be this, they will always work, not always work, I lied. They can work if they're the same size, but they don't have to when it's multiplying. So we'll talk about when and where you can multiply matrices. Now, This is a rows by column. The dimensions of a matrix are the rows by column. So there are 2 rows and 1, 2, 3 columns. So this is a 2 by 3 matrix, and this is also a 2 by 3 matrix. So because they're both 2 by 3, we can add them. And what we do is we match the elements. So we can add this element with this element, this one with this one. We're going to add up everything that are in the same position. So we're going to be just adding all of those up, and that will be my new matrix. So if I do A plus C, that is equal to, let's add the red parts, which is -1. We add the blue part, which is +1. 3 and 7 is 10. 7 and 0 is 7. 4 and 4 is 8. And then the negative 7 and 6 is, in fact, -1. So literally, we just match every element and then add them or subtract them depending on what you're doing. So like I said, they have to be the same size. They're both 2 rows by 3 columns, 2 rows, 3 columns. Then we just, in this case, subtract the elements of C. So in this case, when we do B minus C, we're doing -1 minus a -2, which turns into +2. So it's like +1. Maybe I'll write this out. So we do -1 and then minus a -2. Then we have -4 minus 7. And then 6 minus 4. We have 0 minus a -3. We have 1 minus 1, and then 3 minus 3. This will give me my answers of +1. We'll have -11, +2, +3, that's 0, and that's 0. That will be my new H matrix when I subtract B minus C. So what happens if I multiply and add or subtract or whatever? So then we're just going to rewrite it down as like -6 times this 7, 7, -3, -6, 4, 7. And then we're going to do plus 3 times this 5, 6, -6, 2, 6, and -6. And then we're going to, first, let's multiply everything by the scalars, and then we're going to either add or subtract depending on what that is. So I'm going to rewrite this as -42, -42, +18, +36, -24, and -42 again. And then we're going to add in, or add this next matrix of 15, 18, -18, +6, and 18, and -18. That was a 6 there. And then we just have to add those all together. So when we do that, let's do that real quickly. So that is equal to this, is equal to that, is equal to this. If we add the elements that are together, so -42 and +15 is in fact a -27. 42 and 18, both negative, is -60. 18 and 18 is 36. 36 and 18 is in fact equal to 54. -24 and 6 give me a -18. And lastly, -42, -18 is -60. So that would be my new answer of -60 plus 3e. So how about you try this last one on your own? I will have an answer shortly, so please pause it and try it yourself. So hopefully you got this as your answer. I could have made a mistake, but I think these are right. You can just double check it. And if there is a mistake, just let me know.